Dear students, today we are going to see certain topics in gears and gear trains, so unit 4, okay? So, I'll just show you the diagram and I will explain. This is actually the topic is condition for constant velocity ratio of two three wheels, okay? Or otherwise, we are going to discuss about the law of gearing. You please see the diagram, I'll explain. You can see that we are having wheel 1, the pinion, and the other is wheel 2, okay? These are shown by the thick lines, etc. Let the two teeth be contacted at the point capital Q, and the wheels will be rotating in some directions, etc. Let T, capital TT be the common tangent and MN be the normal. So from the centers O1 and O2, draw O1M. Please see here, draw O1M and also here O2N perpendicular and O2N perpendicular to MN. A little consideration will show that the point Q will be moving in the direction of QC, okay, when it is being considered as a point on the wheel 1, and in the direction of QD when it is QD where it is considered for your wheel 2. So V1, V2 be the velocities of point Q on the wheels 1 and 2, etc. So what we are going to do here is I am going to see it how it is working. So I am checking that the equations that the angular velocity ratio is inversely proportional to the ratio of the distances of the point P from the centers O1 and O2. Okay, so this is actually in common. In other words, we can say the common normal at the point of contact between a pair of teeth must always pass through the pitch point. Okay, so this is the law of gearing. So we have to ensure that this has been being followed. Okay, so next is the forms of teeth: is cycloidal teeth and involutive. The cycloid means actually the curve traced by a point on the circumference of the circle which rolls without slipping, etc. Okay, and if it is rolling on the outside of circle, it is epicycle, and if it is rolling inside the circle, it is called as hypocycloid. Okay, so you can see that the fixed line or pitch line of a rack is being shown. So when the circle C rolls without slipping above the pitch line in the direction as indicated in the diagram, we can see that the point P on the circle traces the epicycloid PA, capital PA. So this will be representing the face of the cycloidal tooth profile. Okay, and if the circle D rolls without slipping below the pitch line, the point P on the circle will be tracing a hypocycloid, which will be representing the flank of the cycloidal teeth. Okay, next is your involute teeth. Okay, what is involute teeth? So involute of a circle is a plane curve generated by a point on the tangent, so which will be rolling on a circle without slipping. Let capital A be the starting point, and the base circle is being divided into points like A, P1, P1, P2, P2, P3, etc. So the tangents at P1, P2, P3 will be drawn, and the lengths are PA1. Please see the diagram. So P1A, like this you will have. Okay, and what happens is the tangents at P1, P2 will be drawn, and the lengths are P1A1, P2A2, and P3A3. And it will be equal to the arcs AP1, AP2, AP3. So we have to join the points AA1, AA2, and we get this, etc. Okay, in other words, normal at any point of the involute is the tangent to the circle. Okay, so what are these advantages of this involute gears when compared with this advantages of this involute gears? What are they actually? So what happens here is the most important advantage is that the center distance for the pair of involute gear can be varied within the limits. So this can be done without changing the velocity ratio. But in cycloidal gears, you can't do this. Okay, we need the exact center distance will have to be maintained. Okay, involute, the pressure angles from the start of the engagement of T to the engagement remains constant. So if this occurs only, we can can ensure the smooth landing and there will be less fears of tears. But what happens in cycloid gears means the pressure angle is maximum at the beginning of engagement and reduces to 0. So it becomes decreasing maximum at the end of it. So what happens is when there is a variation, there will be no smooth running of gears. Okay. Next is we'll be seeing what is the length of arc of contact. So arc of contact means the path traced by a point on the pitch circle from the beginning to the end of engagement. So you please we can see that length of arc of contact means length of path of contact by cos pi. So length of arc of the length of path of resistance by cos pi. So Kp by cos pi divided by PL by cos pi. Okay, I have also given you a diagram on an example so that we can understand it. So if you have number of teeth on two spur gears is in measure of 14, the teeth have 20 degree involute profile and the module is also given as 6 mm. If the arc of contact is 1.75 times the circular pitch, find the addendum. So circular pitch is equal to pi into m, and length of arc of contact we have it as 1.75 pc, we have it as 33 mm. Length of path of contact is equal to this length of arc of contact into cos pi, so 33 cos 20. So capital RA is equal to radius of addendum circle. So circle of pitch capital R is equal to mt by 2. So which we have it as 120 mm. So by using the formula, we get it as length of path of contact we are finding out. Okay. Thank you.